Hello students, in this session I would like to discuss the concept location of roads from the chapter Quadratic Equations and Expressions. Now let us try to understand this particular concept, location of roads. So what is the idea behind this particular concept? It's very simple. I'll consider a quadratic equation like this: ax square plus bx plus c, where a is not equals to 0 and bc are real numbers. And I'll assume three real numbers, some k, k1, k2, which are also real numbers, and I'll assume two roots of this quadratic equation, which are alpha and beta, and I'll assume alpha is less than beta, that is alpha is the smaller root, beta is the bigger root. Now if I impose some restrictions on the roots of the quadratic equation, what could be the conditions? So that's how the problems will be. He will give you a quadratic equation and he will say, if the roots of this quadratic equation are greater than some number or less than some number, or exactly one root of the quadratic equation is lying in some interval, or both the roots are lying in some interval. So in such cases, we would be getting some restrictions. By using the restrictions, I can get the value of the missing number in the quadratic equation. Now let us start with, actually there are some 5 to 6 cases in this location of roots. I'll start with case number 1. Now first case is, if both the roots of f of x equal to 0 are less than a constant k. Okay, so definitely here we do not know whether a is greater than 0 or less than 0, but we will consider both the cases, so we will get the common restriction in both the cases. Okay, for example, if I take a greater than 0, in fact here if the roots of f of x equals to 0 are less than k, you might get equal roots also, isn't it? Now this is x-axis. Now if e is greater than 0, graph will be upward parabola. And just now I told you alpha and beta are the roots of this quadratic equation. Now this is when d greater than 0, two distinct roots. But there is a possibility that roots might be equal also. This is d equal to 0. This is d greater than 0. Understood? Now I said, if the roots of this quadratic equation are less than k, that means definitely k will be the right side of these two roots or this equal root. So let me assume k is somewhere here. I hope you are following what I am saying, isn't it? K. So this is d equals to 0, d greater than 0. So if k is the number which is greater than the roots of the quadratic equation. Now if similarly, if I consider a less than 0 also, it could be something like this. This is alpha, this is beta, and roots can be equal also. Now again, this will be the number k because both the roots are less than k. Now by looking at these two graphs, what are the restrictions on this roots? Now obviously the first restriction will be discriminant is greater than or equal to 0, because I said roots can be equal also. That is one restriction. And what is another restriction that you can think of? Here a is positive. Always look at a. And here f of k is positive or negative? Positive, because this is f of k value. and this is above x-axis, isn't it? Because when a greater than 0 and if k is greater than both the roots of the quadratic equation, definitely f of k value will be positive. A is positive, f of k is positive, and their product also will be positive. And similarly in this case, a is less than 0. And what about this one here? F of k is also less than 0. That means in both the cases, a and f of k are having same signs. So definitely their product will be positive. Plus into plus or minus into minus. So there will be another restriction, which is a into f of k greater than 0. Now, is it the final restriction? No. You can think of another restriction, because we already know that this is vertex which is minus b by 2a. And here also this is minus b by 2a. Now, if you observe this one, minus b by 2a will be less than k. In this case also minus b by 2a will be less than k. So, can I write it something like this? K will be greater than minus b by 2a. So these three inequalities will completely represent or describes the condition where the roots of f of x equals to 0 are less than k. I hope this particular case is very much clear to you. Again, I revise it. I am considering a quadratic equation ax square plus bx plus c equals to 0, and I am assuming that in case 1 both the roots are less than k. In fact, roots are less than k. It might be equal roots or distinct roots. So first restriction is definitely discriminant will be greater than or equals to 0. And in both cases, a greater than 0 or a less than 0, I am getting same sign for a and f of k. So that's how I got a into f of k. And definitely, since this k is greater than the roots, and definitely k will be greater than minus b by 2a, which is the vertex. So this is case 1 of the location of roots. Now we will move on to the next restriction. So in the exam, if you are given with any question related to this case, you can apply these three conditions and solve those three inequalities. You will get the answer. Now, second case. Case 2 is if the roots of f of x equals to 0 are greater than number k. In the previous case, we took roots of f of x equals to 0 are less than k. In this case, I am considering roots of f of x equals to 0 are greater than k. Again, it's the same thing. Draw the diagram and try to get the restrictions. First thing, if a is greater than 0, this is x-axis. Maybe d greater than 0 or d equal to 0. Both roots alpha and beta. Now this will be minus b by 2a, isn't it? Now I said roots of this quadratic equation are greater than k. That means the number k is less than the roots of this equation. So definitely k will be on the left side of these roots. In the previous case, k is in the right side of these two roots r. So definitely here this is f of k. If a is less than 0, again in this case it will be now definitely k will be here because k is less than the roots alpha and beta. So definitely this will be f of k. Now this is minus b by 2a. Now from these two diagrams, we can write down the restrictions. First one, discriminant is greater than or equals to 0. And the second restriction, obviously, a is positive, f of k is also positive. A is negative, f of k is also negative. again this restriction will not be changed. A into f of k will be positive, isn't it? And what about this one? In the previous case we had k greater than minus b by 2m, but in this case k is less than, because this number k is less than alpha and beta, because the roots alpha and beta are greater than k. So in this case k will be less than minus b by 2m. So this is the difference between the previous case and this case. Understood? Now I'll move to the third case. Now case 3. Now case 3 is something like this. If exactly one root of f of x equals to 0 lie in the interval k1 comma k2, open interval. Understood? So this is case 3. I said if exactly one root of f of x equals to 0 lie in the interval k1 comma k2. It is very simple again. Just we'll draw the diagram based on this one and we'll try to write down the restriction. X-axis. Two roots. Now this is a greater than 0 case. Alpha, beta. Now I said exactly one root of f of x equal, that means either alpha or beta belongs to this interval k1 comma k2. Now let me assume alpha is that root which is lying in this interval. So that means alpha must lie between k1 and k2. So definitely if I consider k1 here and if I consider k2 here, somewhere here, I don't know where it is, definitely this condition will depict this picture, isn't it? Because exactly one root of f of x equals to 0 lie in the interval k1 and k2. Is it correct? And it is like alpha is lying between k1 and k2. Now this is one case, a greater than 0. Now similarly, now we will come back to the restrictions later. When a is less than 0, now again here x-axis, alpha, beta. Now again here it will be k1, somewhere here it will be k2, correct? Now based on this information, let us try to write down the restrictions. Obviously it must have two distinct roots, because he said exactly one root is lying in interval k1 and k2. So other root will be something else, okay? So discriminant is greater than 0. Now second restriction, what will be the second restriction? Observe very carefully. This is f of k1, isn't it? This is f of k2. Now no doubt f of k1 and f of k2 are having opposite signs. Is it correct? F of k1 and f of k2 are having opposite signs. So their product will be less than 0. Similarly, here also, this is f of k1. This is f of k2. Now here also, f of k1 and f of k2 are having opposite signs. So in both the cases, we can say that f of k1 into f of k2 will be less than 0. I hope this is clear. I think these two conditions will give you the clear idea about this condition. If exactly one root of f of x equals to 0 lie in the interval k1 comma k2. One thing is discriminant greater than 0 and the other thing is f of k1 into f of k2 is less than 0. In both cases, either a greater than 0 or a less than 0. So this is case number 3. Now let's move on to another case. Case 4. If both the roots of f of x equals to 0 lie in the interval k1 comma k2. In the previous case, exactly one root of f of x equals to 0 lie in the interval k1 comma k2. Now here, if both the roots of f of x equals to 0 lie in the interval k1 comma k2. Now again, we'll draw the diagram and it will be easy. When a greater than 0, right, x-axis. So definitely both the roots. So we will have two distinct roots, alpha, beta. This is x-axis. Now I said these two roots are lying in this interval. So definitely k1 will be on the left side of alpha, k2 will be on the right side of beta. Is it that? Both the roots are lying in the interval k1 and k2. And definitely minus b by 2a also lies in the interval k1 and k2. Similarly, when a less than 0, now again here also alpha, beta, here k1, it will be k2, isn't it? And this is minus b by 2a. Now in these two, from these two diagrams, let us write down the restrictions. First one is d greater than 0, correct? And what about the next one? Look at this k1 and k2. F of k1 positive, f of k2 also positive. So definitely their product will be positive. And what about this one? Here also f of k1 is negative. What about f of k2? This is also negative. Both are having actually same signs in both the cases. So definitely their product will be positive. F of k1 and f of k2 will be greater than 0. And the third restriction, because we have minus b by 2a. So definitely minus b by 2a lies between k1 and k2. So I can write it like this. k1 less than minus b by 2a less than k2. So these three conditions will give me the complete picture of this particular restriction on the roots of the quadratic equation f of x equals to 0, which is ax squared plus bx plus c equals to 0. I hope this is clear. Again, I will repeat this. If both the roots of the quadratic equation f of x equals to 0 lie in the interval k1 comma k2, so f of k1, f of k2. So since it has two distinct roots, discriminant is greater than 0. And one more thing, f of k1 and f of k2 are having same signs in both the cases. When a greater than 0 as well as a less than 0. And one more thing, since roots are lying in the interval k1 and k2, definitely minus b by 2a will belong to the interval k1 and k2. That's why I have written k1 less than minus b by 2a less than k2. So in this particular case, we will get these three restrictions. Okay. Now let us move to next condition or next case. Case 5. I think this would be the last case. Even if you get any other miscellaneous case, again draw the diagram corresponding to the given information and write down the restrictions, solve those 3 restrictions, therefore you will get the answer. Now case 5, in the previous case we discussed if both the roots belong to the interval k1 comma k2. Now in this case we will take in the reverse way. If the numbers k1 comma k2 lie between the roots of f of x equals to 0. The numbers k1 and k2 lie between the roots of f of x equals to 0. Now in this case, again I will consider 2 cases, a greater than 0 as well as a less than 0. Okay. Now if I consider a greater than 0, again this is x-axis. Okay. A greater than 0 case, I said this is alpha, this is beta. Now in this case I am taking both the numbers lie in the interval or lie between the roots alpha and beta. So definitely k1 here, k2 here, if I consider k1 less than k2. Okay, is it okay? Now similarly in this case also, alpha, beta, here it will be k1, here it will be k2, and we are not sure about the location of minus b by 2 because we do not know about k1 and k2, so we don't have to worry about that minus b by 2. Now based on this one, can we write down the restrictions? Yes, one is d greater than 0, obviously. What about the second restriction? k1, k2 both lie in this interval. Now if you observe, f of k1, f of k2 are having same sign, both are negative. In this case also, f of k1 and f of k2 are having same sign. So can I write it like this? F of k1 into f of k2 will be greater than 0. Is it correct? Yes, it is. F of k1 and f of k2 will be greater than 0. Now in fact, if you want, you can completely write a into. No, if I write a into, you don't get greater than sign in both cases. Only f of k1 and f of k2 are having same signs in both the cases. Okay. So this is case number 5. So I hope you understood these 5 cases from the location of roots. Okay. Now let us try to look at some questions on location of roots. Now the question is, simple illustration, if both roots of the quadratic equations x square minus mx plus 4 equals to 0, simple main standard question, are real and distinct and they lie in the interval 1, 5. Then m lies in which interval? So this is the question he has given actually, and this is J 2019 question. Now the options are option 1 4, 5, option 2 minus 5 comma minus 4, and option 3 3 comma 4, and option 4 5 comma 6. So this is a simple question based on location of roots. He said if both roots of the quadratic equation x square minus mx plus 4 equals to 0 are real and distinct and they lie in the interval 1 comma 5, then m lies in the interval. Okay, now I think we have already discussed this particular case. Both roots belong to this interval 1 comma 5, isn't it? So it is like k1, k2, isn't it? Now if you draw the diagram, here x square quotient is 1 positive, so it will be upward parabola. Now if I draw the simple diagram to understand it clearly. So these are two distinct roots. Let me assume them as alpha and beta. Now he said these two roots are lying in interval 1 comma 5. So definitely 1 will be on the right side of alpha, 5 will be on the left. So 1 will be on the left side of alpha, 5 will be on the right side of beta. So and this is minus b by 2a. Now no doubt the restrictions will be, first thing is discriminant greater than 0. What will be second restriction? F of 1 and f of 5 both are positive, isn't it? So f of 1 into f of 5 will be greater than 0. And what about third one? Minus b by 2a is lying between 1 and 5. So 1 less than minus b by 2a less than 5, isn't it? Now if I take the intersection of these three inequalities, I will get the answer. Understood? So this is the simple question actually. This is actually case 4 I guess, which we discussed just now. So both roots alpha and beta are lying in interval 1 and 5, isn't it? Then we need to determine the interval for m. As I already told you, he will skip one coefficient from the quadratic equation and he will give you some restriction on the roots, and based on that restriction you have to write down these 2 or 3 inequalities, and if you take the intersection of these 3 inequalities you will get the answer. Right. Now let us continue with the calculation. So f of x is x square minus mx plus 4. First thing is discriminant greater than 0. That is b square, that is m square, minus 4ac greater than 0. Now this will be equal to m plus 4 into m minus 4 greater than 0. And we already know that by the method of intervals, it will be m less than minus 4 or m greater than 4. Let me assume this is restriction number 1, inequality 1. Now next one, f of 1 into f of 5. Greater than 0. Both will be positive. Now what is f of 1? 1 minus m plus 4. So this will be 5 minus m. I will write directly. f of 5, 25 plus 4, 29 minus 5m greater than 0. Now can I write it like this? m minus 5 into 5m minus 29 greater than 0. Now again by method of intervals it will be m less than 5 or m greater than 29 by 5 because 5 is less than 29 by 5. Now let me assume this is inequality number 2. Okay. Now finally what is the third restriction? 1 less than minus b by 2a less than 5. Isn't it? Now 1 less than what is minus b? What is b here? Minus m. Minus of minus m plus m by 2a. 2 into 1, 2 less than 5. So this will be 2 less than m less than 10. So this is inequality number 3. So definitely if you take the intersection of these 3 inequalities, you will get the answer. Now let us try to solve it. And finally the answer will be minus 4, 2, because 2 is there, and next one will be 4, next one will be 5, next one will be 29 by 5, next one will be 10. This is x-axis. Now take the intersection of these three. M less than minus 4, M greater than 4. Next, M less than 5, M greater than 29 by 5, and M is lying between 2 to 10. So, what will be the common region here? Where 3 lines, 3 common lines. So, definitely this is one common region. I hope you are following. And there is another common region, 29 by 5 to 10. So, finally, M belongs to either 4, 5 union 29 by 5 to 10. Since it is a single correct question, J mains question, and we have 4, 5 as option, so definitely option 1 will be correct. Understood? So this is how we have to solve question based on location of roots, and it will be a very simple question if it is a J mains question. Again, I'll repeat it. He said both the roots are lying in the interval 1, comma. It is like both the roots lying in interval k1, k2. So same thing. Discriminant greater than 0, one restriction. F of 1 and f of 5 greater than 0. And finally, minus b by 2 is lying between 1 to 5. So answer is 4, 5. So this is one of the good examples of location of roots which was given in recent JEE exam. Now let us try to look at few more questions on quadratic equations and expressions as a whole. One question of that type, very simple question. Number of real roots of the equation x square plus x by x minus 1 whole square equal to 8. So this is the question. Number of real roots of the equation x square plus x by x minus 1 whole square equals to 8. Now options are 1, 2, 3, 4. Now let us try to solve this simple question. First thing is, usually we have a tendency to simplify this one. We will take LCM as x minus 1 whole square, but you will get a quadratic equation. But instead of that, what I will do is, I will convert this one into a quadratic equation in terms of some other value. It is something like this. Observe very carefully. X square plus x by x minus 1 whole square. It is like a square plus b square. Can I write it as a plus b whole square minus 2ab, isn't it? That is a into x by x minus 1 equals to 8. Correct? Now if I simplify this one, if I take LCM, x into x minus 1, x square minus x plus x minus x will be cancelled. I will get x square by x minus 1 whole square minus 2 times x square by x minus 1 minus 8 equal to 0. Now what is the advantage of doing like this? Now if you observe this one, it has become a quadratic equation in x square by x minus 1. Is it correct? So this first step is very important. X square plus x by x minus 1 whole square, I am writing this one as x plus x by x minus 1 whole square minus 2 into x by x minus 1. So it is like x square by x minus 1 whole square minus 2 times of x square by x minus 1 minus 8 equals to 0. Now I'll assume this one as let x square by x minus 1 as some k. Now this is a simple quadratic equation and we can solve it. Now if I substitute, I'll get k square minus 2k minus 8 equals to 0. Now if I factorize this one, 4 2s are 8 minus 4 plus 2. So it will be k minus 4 into k plus 2 equal to 0. Is it correct? Now finally I will get k equal to 4 or k equal to minus 2. But we need to find the values of x, isn't it? Number of real roots. So I consider these two cases and I'll verify how many real roots I am getting. So first I'll take a equal to 4, that is x square by x minus 1. Or I will take a equal to minus 2, which is again x square by x minus 1. And I will get two quadratic equations. And if I solve them, I will get the number of real roots. Now if I continue with the remaining calculation. If k equal to 4, that is x square by x minus 1 equal to 4, I will get x square minus 4x plus 4 equal to 0 directly, isn't it? 4x minus 4 to the left side. So it is a perfect square. X minus 2 whole square equal to 0. So definitely x equal to 2. So from here we are getting one real root, isn't it? Now one more thing. K equal to minus 2. If k equal to minus 2, I will get x square by x minus 1 equal to minus 2. Again, if I simplify this, on x square plus 2x minus 2 equal to 0. And I think from here you will get irrational roots. He is just asking the number of real roots, right? So definitely here discriminant is b square minus 4ac, which is greater than 0. So from here you will get two real roots. And in the previous case, we have already got one real root. So totally there will be three real roots for this equation. So this is one of the equations which belongs to the model, converting the given equation into quadratic equation. Okay.